Okay, hello and welcome everyone. So this video is going to be a walkthrough of the second exam for Principles of Micro class. I'll show the exam questions first and give you a chance to, well, if you didn't take the exam and you want to use this to practice, I'll go kind of through the entire exam here. There are 22 multiple choice questions and then 3 kind of free response or like longer form mathematical essay type questions. So I'll show all those right here. The exam covers like gains from trade, comparative advantage, international trade, consumer and producer surplus, efficiency, did I say international, international trade, externalities, public goods, labor demand, labor supply, labor equilibrium, min wage, and so on and so forth. So some of the other stuff from earlier in the class, certainly relevant, like basic supply and demand model, 4 core principles of economics, elasticity, price controls and taxes. But for those things, we're pretty much assuming you've just got like working knowledge, working ability to be able to apply those things. Right? All right, and then here's 22. I don't know, probably easy enough to like stop the video and then kind of work each of these questions. And then what I'm going to do like immediately after I do this is I'm going to show the solution just like real quick, just in case like you don't want to see the explanation, you just want the solution. Let me go do that now. So, right, here's the solution for the multiple choice. All right, and then for the short answer, making myself car sick. All right. Good. Good. All right. I'm getting so bored doing this. So hopefully you're not as well. Maybe you're waiting for me to do something cool. How about this? There's Howard. There's Dudley. Howard, Dudley. Right? From right here, Howard and Dudley. Okay. Whatever. So I'll go over each of these a little bit more deliberately now. For all economies, the extra external benefit accruing to bystanders from one extra unit of production, it's the marginal external benefit. So that's just true by definition. It's not marginal external cost. We're talking about benefits. It's not corrective tax, right? Because we want to set that equal to the size of you want to set that equal to the size of like a cost or a benefit. But actually, in this case, if you have an external benefit, that you'd probably actually have a corrective subsidy. It's not a technology spillover, but this is like true by definition, right? Okay, so a person with the lowest opportunity cost of producing a particular good is said to have comparative advantage. Again, true by definition. Considering the labor market, predict which of the following create an incentive for investment in capital. So who's making the investment in capital? The firm is, right? So think about the firm. They're making the choice between hiring workers or hiring machines or AI or whatever. Higher wages are going to be cited as a reason for increased automation, right? When we talk about like McDonald's wanting to implement more kiosks, well, if the wage rises, right? Remember that was always, so like 8 years ago, people were concerned if we raise the minimum wage to $15 an hour that McDonald's is going to replace all their workers with kiosks. Well, now it's, in northern Michigan, it's $21 an hour is what I've now seen 2 McDonald's offering jobs at $21 an hour in northern Michigan. So, right. The demand for factors of production is known as derived demand because it is derived from the demand for the outputs produced by the factors of production. Right? This is the idea that, nobody wants like lithium, right? Nobody wants lithium for itself. Why is there like a big market for lithium? Well, people want electric vehicles and electric vehicle batteries, right? So the demand for these batteries from Tesla and some other companies, and the demand for the batteries is derived from the demand for the cars, right? So here I've got this nice chain of derived demands. But the demand for the lithium is derived from the demand for the batteries, and the demand for the batteries is derived from the demand for the electric vehicles themselves, right? Demand for the factors of production is known as derived demand because it's derived from the demand for the outputs produced by the factors of production. Derived from the available supply factors such as land that can be overexploited. No, not easy to determine, must be derived by a technical and often complicated process. Maybe like you think of like derived, like calculus or something. Derived on the basis of questions posed to residents during the census. All right, so a corrective tax designed to resolve negative externality problem is typically set to an amount equal to, well, negative externality means we want it to be equal to the marginal external cost, because the difference between the marginal private cost and the marginal social cost is the marginal external cost, and that's what we want to set the corrective tax equal to if we wanted the decision makers to internalize the externality, right? The idea is the marginal external effect is non-salient and not readily quantifiable for our decision makers themselves. So that's why we have the externality problem in the first place. However, if you set an optimal corrective tax equal to the size of the marginal external benefit, then a decision maker will pay attention to the price increase due to the tax and behave as if they're paying attention to the marginal external cost, paying attention to the externality. U.S. has a comparative advantage in high-skilled labor. This explains why the U.S. is a net importer of manufactured goods, right? We have a comparative advantage in high-skilled labor. That's right. So it's got to be A or B. And then are we a net exporter or a net importer of manufactured goods? We're an importer, right? Okay. So higher wage may at some point induce an individual to work. When this happens, the labor supply curve is, okay, so it could be harder vertical, nope. More horizontal, nope. Less backward bending, more backward bending. Oh, okay, so higher wage at some point may induce an individual to work. Well, it's got to be work less backward bending, right? So the reason why is, remember, this is when the income effect dominates, and the idea is we have our labor supply curve, and when the income effect dominates, it looks something like this, right? The idea is as the wage rises, so wage is like on the vertical, quantity is on the horizontal. I didn't think this through before I started doing this. I thought this was going to work. That's a Q, by the way, for output. I don't know. That's so annoying because I'm trying to draw the line through there. Okay, cool. So this would be when the income effect dominates. When the substitution effect dominates, that's when we get like our standard upward sloping labor supply curve. And we get our backward bending labor supply curve. Of course it's going to do that. Looks kind of like this, right? Yeah, that's perfect. That's what we want to do. Not this. I don't know what that thing's doing. Okay, so this is like a backward bending labor supply curve. So this is like, you know, here again is like quantity. I have so many pictures on here. Just let it clear this off. It's all right, whatever. So the idea is at higher and higher wages, what happens? Initially, the higher wage is going to make working relatively more attractive compared to your other options, right? So if you get a raise, you're like working an hourly job and your wage is higher. You know, like for me, I'd get like a dollar wage or dollar increase every summer. So I started at like $5.61, and it's basically a dollar increase every summer for like 5 years or something. Well, it's less than that. Okay, whatever. So at the higher wage, though, I'm interested in working more, right? So the wage rise was happening faster than the increase of the opportunity cost of my time, at least over that period of time, right? And so as my wage rose, I was interested in working more and more hours. Some summers I'd work my 6-hour shift, another 6-hour shift, and then I'd pick up an hour in the morning, an hour in the evening, and then I could get 14-hour days, something like that. 14-hour days. Anyway, so at a certain point, then when the wage is higher and higher, what ends up happening? Well, now people want to work less, right? So that's why we get this backward bending labor supply curve at higher wages, right? At some point may induce an individual to work less, right? Labor supply is backward bending. So this is where you have maybe some amount that you want to be able to earn, and then you realize, oh, I don't need to work all the time to be able to hit that level. In fact, I'd rather buy back some leisure time, right? So the idea in like economists, labor economists have the idea that this is a pretty good model for most people's labor supply decision. It's just that it varies on the individual, like where that break point is, right? So we assume like as your wage rises, you'll be willing to work more and more and more and more. But at a certain point, you're going to work less because you want to be able to enjoy your time. So, all right, the market for concert tickets. I don't know if there's a good way to clear this all off. This is super distracting. So, the market for concert tickets is in equilibrium. The fire marshal tries to reduce the number of tickets sold, other things equal, economic surplus will. Well, if it's already in equilibrium, and now we've got this regulation to reduce the quantity, that's going to introduce deadweight loss, and so economic surplus is going to decrease, right? Because Cornell can type faster and more accurately than Alice, Cornell has absolute advantage, right? Absolute advantage. To say something about comparative advantage, we have to know that that they can produce at the lower opportunity cost. Aluminum mining operation discharged waste products into a river, causing higher costs and discomfort for downstream users of water, for which they are not compensated. This is a negative externality situation. There's overproduction of aluminum relative to the socially efficient level. Why? Because the producers, the aluminum mining operation, isn't paying attention to this additional higher cost and discomfort for the downstream users. They're ignoring the negative externality. So we're getting overproduction, right? Well, we'll see a picture of the negative externality in a second, so I don't want to continually cluttering up this page. In a monopsony labor market, employees bargain with market power through a union. No, although that's about the only way you could counterbalance the monopsony. What's a monopsony? So you might think this is, the first time I saw this, I thought this was spelled wrong. I thought it was monopoly spelled wrong. No, monopsony is if you have a single buyer, right? So monopoly is if there's like a single seller of the product. Monopsony is if there's a single buyer. And so, yeah, I mean, it would be good for employees to have a union to be able to negotiate with a monopsony, but actually, lots of times what will happen is the monopsony is going to not want to deal with the union, right? And because they are the only buyer, they actually have kind of a lot of power to try to block the union from forming in the first place. So anyway, so this certainly, so it's not A, so that doesn't happen. This makes it seem as though it's by definition. That's not what happens by definition, although it's like the one way to kind of counter monopsony labor power. Anyway, so employees have an advantage due to their human capital? No, not at all. If the employer uses an attractive benefit package to attract good employees, no, they don't need to because they're the only show in town. The employer pays a low wage. Yep, that's what happens. Because if you're the only, think of this, you have a market where there's like one factory that employs everyone in the county, right? What's going to happen? They don't have to pay a very high wage because you don't have any good options. Like you'd have to drive or commute really far, you'd have to move or something like that. And so they can pay comparatively lower wages up to the point where it's better to just pack up and leave entirely. So yeah, monopsony labor market, we'd expect the employer doesn't have to compete with other prospective employers. They're the only one that's offering jobs to any of the available workers. Government increases training requirements to obtain an electrician's license. What impact does this have on the market for electricians? Well, so higher licensing requirements is going to reduce the labor supply. So we're going to get a leftward shift of the labor supply curve. And then with the leftward shift of labor supply, we're going to get a higher wage and a lower quantity. So that's this right here. Supply of electricians will decrease, resulting in a higher wage and a lower quantity of labor. Deadweight loss of an inefficient market is calculated by first identifying the actual quantity produced and sold. Because we want to know, we want to know what's the amount, what's the quantity transacted. Here would have been the market equilibrium, but we want to know where's the quantity transacted. For there to be deadweight loss, we probably have something like right here would be where the so I don't know if I can move everything. Yeah, so like we have to find where's the quantity transacted, and then deadweight loss would be like right here. It's not marginal cost benefit ratio. It's not average cost of production. Those two really don't make any sense here. It's not the price compared to the ideal price. We don't really have like an ideal price. You might want to read ideal price as like the market equilibrium price, but that's even bold, right? Because like when we talk about ideal price, there's value judgment there. And who's ideal? The ideal price for the monopoly is high. The ideal price for the consumer is low. So this one actually kind of doesn't even make any sense. But even if you read this as equilibrium price, that's not right. Because remember, like, what's really bad about deadweight loss isn't, so let's just focus on like the deadweight loss created from in international trade by a tariff, right? So remember, like, the international trade tariffs input picture or imports picture. So like my bottom one would be like the world price, right? My top horizontal line would be the world price plus the tariff, right? So this would be, okay, so this is like price, this is quantity, this is like domestic supply, this is domestic demand, this is going to be the world price, this is the world price with a tariff. This right here would therefore be tariff revenue. This right here, this little triangle, would be the additional inefficiency because the domestic producers that are allowed to produce or that are invited back into the market at the higher price have artificially higher costs. The deadweight loss is right here. It's this triangle. This corresponds to goods that are not produced or consumed. And when we talk about this being deadweight loss, we don't say the problem is that they're paying a high price, right? We're not observing the fact that the price here is higher than the prices here. We're observing the fact that these units aren't produced or consumed. And that's bad because the demand curve is higher than the price, right? And so when we're explaining deadweight loss, we're always talking about like foregone or like mutually beneficial gains from trade that just don't occur, right? So that's what's relevant. That's why like focusing on quantity is important. Countries benefit from trade by exporting goods in which their opportunity costs are relatively low and importing goods in which their opportunity costs are relatively high. So that's almost true by definition, right? So we're thinking about the link between comparative advantage and opportunity costs and then trade, imports and exports. What type of good is rival and excludable? By definition, private goods, right? So rival are goods that when you consume, there's one less in the universe for everyone else. Excludable means you can limit who's able to consume. Private goods are goods that are rival and excludable. Club goods are non-rival but excludable. That's like concert tickets or sporting event tickets or something like that. Common resources are rival but non-excludable. So this is like space on the beach or like clean air or groundwater or something like in an aquifer. Public goods are non-rival and non-excludable. So it's like national defense. Think of like maybe a fireworks display. When non-wage worker benefits are increased at a company, the company's demand for labor will blank because employees are to the company. Demand for labor will decrease because employees are more costly. So that's this one. To kind of think about like what's going on here, non-wage worker benefits, who are paying those? Company pays this. This is like health insurance. This is like other types of benefits that are offered by the company, right? So they're paying for it. That's raising the cost of acquiring each worker. And so, yeah, the labor demand is going to decrease because workers are more costly. An employer should hire one more worker if the marginal benefit exceeds the marginal cost. And what's the marginal benefit of one more worker? The marginal revenue product, right? So marginal benefit is marginal revenue product or marginal revenue product. And remember we said that was like output price times marginal product or PMP. And if we're talking about labor, PMPL, right? So marginal revenue product is the output price times marginal product. Marginal product is the additional output produced by using one more unit of that productive resource. We have to know how much that's actually worth though. And so to do that, we scale it, we multiply it by the output price. So the marginal product is like I hire one more worker and I'm able to like snow blow like 3 or 4 more driveways. So the marginal product is the 3 or 4 more driveways from that additional worker. But what's the value of that? Well, I have to think of what's the market price of 3 more driveways plowed, right? So I multiply it by the output price, and that gives me my marginal revenue product, which is the additional increase in value to the company from hiring that additional worker. So this is a lot of development, but I need this on number 19. So that's why I did that. Employers should hire one more worker if marginal benefit exceeds marginal cost. Which must be true of negative externalities? Well, marginal social cost exceeds marginal private cost. Market price is less than the socially efficient price. So it's really helpful just to think of, as soon as you see like the structure of this question, what's it doing? Here's the marginal private benefit. Whoops, here's the marginal private cost. Here's the marginal social cost. And then here's the market quantity. And then here's the socially efficient quantity. So what happens? Marginal social cost exceeds marginal private cost, and the market price is less than the socially efficient price. Yeah, marginal social cost, that's right here, is higher than marginal private cost, and the market price right here is less than the socially efficient price here. Yep. Okay, and then I'm going to bring this down because as promised, oh, of course, it's not going to go on that page. Of course. Just being clever. Or I could, like, maybe, okay, fine. Look at that. So it wasn't going to let me bring that into this, and I thought I was going to copy paste, but hey, look, I can just set it up like this and it works just fine. All right, so suppose medical research provides evidence that eating cherries provides far greater health benefits than was previously thought. The resulting increase in demand for cherries. All right, so we're going to get an increase in demand for cherries due to this increase in consumer tastes and preferences for cherries, right? Increase in demand for cherries, right? So if this is the market for cherries, we're going to get a rightward shift of demand. Rightward shift of demand, increase in demand is going to drive up the price for cherries. Of course it draws the arrow down. It could have just drawn like a regular line. I would have drawn the arrow point, but no, it decides to whatever. So price is going to rise, quantity is going to rise. All right, so the resulting increase in demand is going to increase the output price. And then our question is, like, what effect is that going to have? Well, the output price increases, right, for cherries. The price of cherries rises. That's the output price. Here's the marginal product of cherry pickers. So marginal revenue product rises, so it's B. Increases the marginal revenue product of cherry pickers for any given number of cherry pickers, right? It's not A, increases the marginal product of cherry pickers, because the marginal product of cherry pickers is going to be like how many additional cherries are we able to get when we employ one more cherry picker. So, so northern Michigan's big for picking cherries or growing cherries. I don't know what a cherry picker is. I don't know if we're talking about like people or if we're talking about like those chairlift ladder things. Either way, if we're talking about individuals or if we're talking about like the capital, the marginal product is how much additional cherries you get from one more cherry picker. But that's not going to be affected by whether eating cherries is good or bad for you, right? That's only going to have to do with like the efficiency or the productivity of the cherry picker itself. All right, increases the supply of cherry pickers? No, it's not going to have any impact there. So that, by virtue of like losing A, discounts actually both D and E. So now we have to focus on just B and C. No, it's definitely B. Okay, so table provides a number of minutes it takes for Bruno and Sasha each to change a tire and iron a dress shirt. Use the data to answer the question. When changing a tire, Bruno's opportunity cost is and Sasha's opportunity cost is. So changing a tire is going to take 60 minutes. Ironing a dress shirt is going to take 40. These are minutes. This is like the productivity. This is like how much time, what's the time requirement, right? This isn't outputs. If you get this reversed, if you get this backwards, you might have thought of these as being like the number of tires or something, or like outputs. No, this is minutes, right? Number of minutes that it takes. All right, so Bruno's opportunity cost of changing a tire, that's 60 minutes. That's more than enough time to do a dress shirt. Matter of fact, it's enough time to do one dress shirt plus a little bit more, right? 60 divided by 40 is what? 1.5 times the requirement necessary to do a dress shirt, right? Because you're going to do 60 minus 40 is 20. So you're going to have 40 minutes, which is enough to get one whole dress shirt. And then you get an extra 20 minutes, which is half a dress shirt, right? So it's going to be 1.5 dress shirts ironed. And then actually, that gives us the answer. We actually don't even have to calculate for Sasha. It turns out it is 1.67. 75 divided by 45 is 1.67. All right, so World price inclusive of trade costs of a pound of apples is lower today than the equilibrium price in the U.S. without trade. Okay, so the price is lower than the equilibrium price in the U.S. without trade. So the U.S. lacks a comparative advantage, so the U.S. should import apples. Compared to the situation without trade, which of the following correctly describes some of the consequences for free trade in the U.S.? Okay, so we want to import apples. We want a lower price as a result of importing the apples. We want consumer surplus to rise. We want overall surplus to increase. Maybe producer surplus fall. So it's E. Domestic price of apples is lower. Consumer surplus is higher. Total economic surplus is higher. And then I was just speculating what I was going to find out. It didn't say anything about producer surplus. That's okay. So the best answer is going to be E. Let's check this. Domestic price is higher. Consumer surplus is lower. No, because we're going to import, right? So what's going to happen with trade? We're going to import. So consumer surplus would be higher with trade. So it's not A. Well, that's enough to cross it off. Let's just leave it like that. Domestic price is the same, but firms export apples. That's silly. Why would? There's no incentive to send the apples out of the economy if the price is the same. Americans import apples. Consumer surplus is higher. Okay. Total economic surplus is lower. No. This is a free trade situation, so it can't be this. We want consumer surplus to rise, but economic surplus to rise too. Americans export apples. Consumer surplus is lower. Total economic surplus is lower. No. So not only are we not exporting apples, but if we did export apples, because it'd be a free trade situation, total economic surplus. Okay, so if we were exporting apples and had a comparative advantage in apples, then total economic surplus would be higher. Actually, here, if we exported apples, that'd be a really bad idea. So yeah, then I guess consumer surplus would be lower. Total economic surplus would be lower. But we have no reason to think that we would export apples. Definitely D is not the best answer. E is definitely the best answer. All right, so suppose you want to show the minimum wage has a small impact on employment. It'll help your argument if you can show in the market for unskilled labor, demand is really inelastic. I don't want to draw it quite that inelastic. All right, so I'll draw inelastic demand. I'll draw a pretty elastic supply, and then I'll draw a horizontal line for minimum wage. So employment, we want to help employment. Employment is the number of jobs offered and filled. So that'd be like comparing the number of jobs offered and filled in the equilibrium to what happens with the minimum wage. And with really inelastic demand, the quantity doesn't decrease by very much at all. The other way to look at that, I don't know, maybe this is the way that I kind of like looking at it. If demand's inelastic, then demand is really unresponsive to this price increase. So yeah, the quantity of labor demand is going to fall, but not by very much because demand is so unresponsive, right? And then actually for all the others, you probably need to, actually the easiest way is probably drawing a combination of these pictures to see why it can't be any of the others. But the best answer is definitely D, demand is inelastic. For this reason here, that's the picture, right? That these quantities, this is just a little bit to the left of the original equilibrium quantity. All right, so Greg has two dogs. Howard and Dudley collaborate to produce mayhem. The only two activities are digging and destroying socks. Howard and Dudley work 24 hours a day. Each hole takes Howard 4 hours to dig. Each sock takes 1.5 hours to destroy. Each hole takes Dudley 3 hours to dig. Sock takes 6 hours to destroy. When working on their own without specialization, Howard digs 4. Dudley also digs 4. Okay, let's just we're going to disregard this fact because this is just talking about like a special circumstance. What's the maximum amount of holes that Howard digs? So this is asking, what's the most? What's the max? How much could Howard possibly do? And what's the max? What's the most Dudley can possibly do? So here we want to think about in terms of 24 hours. So for this term, like we had GSI's announce that we wanted to focus on, maximum. What's the most you could possibly do by yourself, right, in the 24 hours. So here we're looking specifically for 24 hours, right? So we wanted to see 6 holes and 18 socks, right? We want to see what's the most that Howard could possibly do. And same thing for Dudley, 8 holes and 4 socks. We're not going to use the 4 holes and 4 holes here until the very end. All right, so this is what we were looking for. And then I think we awarded half credit if you didn't get the maximum amount that they could possibly do. All right, so in the 24 hours, and the reason why we need maximum amount is because that's necessary to be able to identify opportunity cost and comparative advantage. So, all right, so 24 hours, we dig 6 holes or 18 socks. So let's divide this through by 6. 6 over 6 is 1, 18 over 6 is 3, so 1 hole or 3 socks, or 6 holes or 18 socks, 1 hole or 3 socks, right? And then, therefore, the opportunity cost of 1 sock is 1/3 hole. For Dudley, it's 8 holes or 4 socks, or 8 divided by 8 is 1, 4 divided by 8 is 1/2, right? 1 hole or 1/2 sock, or 1 sock or 2 holes. Okay, so who has the comparative advantage? I like looking to see which is the smallest number that we've identified. It's 1/3 right here. So Howard has the comparative advantage in destroying socks, right? If Howard has a comparative advantage in socks, Dudley must have a comparative advantage in holes. So sure enough, Dudley's opportunity cost of 1 hole is 1/2 a sock, but Howard's is 3. Okay. So then if they're able to specialize in trade, collectively end up with the same number of holes as dug before, how many more socks are they able to destroy? Suppose they each made 4 holes. That cost Howard 12 socks, so Howard can make 6 socks. This costs Dudley 2 socks, so Dudley can make 2 socks. Or 4 minus 2 is 2 socks. So that's a total of 8 socks. So they'd get 8 holes and 8 socks. However, there's 10 more socks are available via specialization, right? They're comparing the 8 socks to 18 that are available when we specialize. Okay, so United States, specifically California, produces avocados, holds a comparative advantage in avocados, so should export. So using the model, we want to show domestic demand, domestic supply, world price. You have to draw the world price above the equilibrium price and have to identify quantity demanded at the world price, quantity supplied at the world price. That's going to give us a surplus. This surplus is going to correspond to exports, and you have to label it as exports, right? So we know that this is an export situation. Then what do we want to do? Well, let me just kind of comment because I'm going to ask about winners and losers. So what happens is at this higher price, there's some new output, right? These sellers, domestic sellers, remember, theory of supply is theory of marginal cost. These sellers have costs that are higher than domestic demanders were willing to pay. So there is no reason for these domestic suppliers to produce the units between Q star and QS at the equilibrium price. However, the world price, now they've got domestic consumers who are willing to pay much more, matter of fact, more than it costs them to produce. So they ramp up their production all the way out to here. So from Q star to QS, that's new production that's produced and then sold abroad. What happens over here, these units between QD and Q star, these are domestic consumers' benefit, right? Theory of demand is theory of marginal benefit. This is how much they're willing to pay for these units, but they're getting outcompeted by the benefit, right? The higher price that foreign consumers are willing to pay. So this is basically like, why would I sell it locally when somebody abroad is willing to pay substantially more? You're going to sell abroad. So what happens is these units are new production that generates new surplus. And then these units right here are just redistributed from these domestic consumers to foreign consumers instead. So that's what happens with exports. As a result, who are our winners and losers in the U.S. and abroad? Well, the winners are the U.S. producers and the foreign consumers. The losers are the U.S. consumers and the foreign producers. 2 points each, basically like 1 point for producers, 1 point for consumers, and then 1 point for consumers, 1 point for producers in the other country. Like abroad. Company in Kakana produces paper as a byproduct, emits a terrible stink that affects drivers going past the city on Highway 41. Model this situation using supply and demand diagram. So we want to have negative externality situation. Here's our demand or marginal private benefit. Here's our marginal private cost. Here's our marginal social cost, which includes the size of the externality right here. Right? The distance between these curves is the externality. Here's the market quantity. Here's the market price. Here's the socially efficient quantity and the socially efficient price. Right? Does the Coase theorem provide a guidance to the solution? No. 2 points for saying no, and then 2 points for the explanation and alternative. Kind of use your good judgment to kind of tell us what could happen. Maybe internalize the externality through a tax or some type of cap and trade or something. I don't know. So the reason why the Coase theorem doesn't apply, what's the Coase theorem? It says that if it's costless to negotiate and if property rights are well defined, it doesn't matter who originally has for instance, the right to pollute, we'd expect that our decision makers are going to come together and bargain to the efficient outcome. That's not going to happen here. Why? It's not costless to negotiate because you've got all these drivers, right? Anyone who drives past is going to be affected, right? It's going to be prohibitively difficult to get all those stakeholders, everyone possibly affected, all the bystanders, to negotiate with the company, right? Like I drive by there. I haven't driven by there in years, but like, nobody's ever asked me to bargain with the company. Instead, just everybody knows Kakana stinks. So it's got a reputation that's now going to extend beyond northeastern Wisconsin. But anyhow, hope you enjoyed the video. Hope you enjoyed the test, and then I'll see you next time.